Let's begin the discussion of examples. Now here we have this question where we have to find out the domain and the range of this given function. Now the domain and range has to be found out by us. So domain is the set of possible values for x for which the function is defined. So as we can see, y is equals to 1 by 2 minus cos d of x. And if this particular term becomes 0, then a function will not be defined. So let's see whether this function, this particular term can become 0 on what value of x. What is the range of cosine? What is the range of cos theta? What is the maximum value of cos theta?
The maximum value of cos theta means I couldn't understand.
I studied trigonometric ratios and the maximum value of cos theta. Its graph like this axis is theta, this axis is cosine of theta, and it starts with its maximum value, goes down, and sinusoidal graph. So the maximum value of this is +1. The minimum value is -1. Okay.
Okay, sir.
So here, as we can see in the question, cosine function is for this term to become 0, cosine function has to be equals to 2, which can never be because the maximum value of cosine function is 1. So it cannot be 2. So it is not the case for any value of x. So for if you take any x, the function will be defined and this term will never become 0. So a domain, we can say, we can take ax as any real number. So our domain, as we can safely say, is real numbers. Okay.
Yes, sir.
So the domain is R. No, not these two options. B and C will be eliminated because they have rejected certain elements from real numbers 1 and 2, which is not the requirement. So these options are eliminated. Now let's discuss about the range. Okay. So we have to find out the range of y. Right? We have considered f of x is equals to y. So 1 by 2 minus cos 3x. Now finding the range of y, as we first know that let's write it as cos 3x 2 minus cos 3x is 1 by y. Okay, and separately we know cosine function cos of theta has maximum value as 1 and minimum value is -1. So if we write 3x on place of theta also, so the function's range will remain the same. And if we multiply negative sign throughout this inequality, so -1 will be +1. The inequality sign will be changed because of multiplication of negative term. Minus of cosine 3x, negative inequality will be changed because of negative multiplication. 1 minus 1. So we can write it as 4 minus of 1 minus cos 3x plus of 1. Clear? Any doubt?
Yes, sir.
Okay, so is this visible clearly, right?
Yes, sir.
Now adding 2 in this inequality on all sides. So 2 minus 1 becomes y2 to make this we are finding the range of this. So adding 2 minus 1 becomes 1, 2 minus cos 3x, 2 plus 1 becomes 3. Now we have to find out, we have found out the range of this. So this is 1 by y. So replace it with 1 by y. Now let's try to find out its range. Okay. So if and 1 by y is less than 3. So y is less than 1 and y, sorry, yeah, y is less than 1. Okay. Y is, sorry. Let me write it. Y will be cross multiplied. So this is simple. So 3 will be come down and we'll replace position with y. So now we have merging both of these inequalities. Y is greater than 1 by 3, less than 1. So we can write y's values are existing. 1 by 3 is included and 1 is also included. So this is the range of y. These are all the possible values of y, which is our f of x. And if we have found out the all possible values of f of x, then it is a range. So range should be 1 by 3 and 1. So A should be our answer. Clear?
Yes, sir.
Any doubt?
No, sir.
We have found out the value of domain by where the function will be defined. We know that if denominators become 0, then function will become not defined. We have studied this in indeterminate form. 1 by 0 is an indeterminate. 1 by 0 is indeterminate. And range is basically the all possible value set of all possible values of f of x. We have considered f of x as y, and then we have solved and solved and solved, and we have found out the all possible values of y in this method. And if you ask that how we will get to know that we have to use this method, as you will solve questions as you will solve questions ahead, and we'll see, we'll observe the same pattern, like most of the time we are using this or some other pattern, then we will be able to know that how to use this, how to use and how to find and which method to be used in what question. Okay.
Yes, sir.
So let's now move ahead. Yes, our answer is correct. They have also used the same method, I guess. Yeah. Their solution given domain is not clear, so refer that if you read the PPT. Coming to this question, if the function is defined from, like, the range is real numbers and codomain is a set given by the function is given is a surjection. Surjective functions are what? What are surjective functions? What are onto functions? What is an onto function? What
On
defines and makes a function onto?
on on to functions.
Hmm.
Sir, in onto functions there will be no codomains remaining.
Yes. All the codomains are getting mapped. This is
Ma'am.
more right way to say, yeah. So codomain is called to range, and the function is given like this. And there's this is the domain, and this is codomain, and we have to find the codomain given that this it is a surjective function. So basically, first the function is given, its domain is given, so we'll find out its range. And as range is equals to codomain, so here in the case of onto functions, so we will announce that this is a set A. So basically, we need to find out the range. Okay.
Yes, sir.
Okay. So for finding out its range, um, considering f of x is equals to y x square upon x square plus 1. So we know that x are all real numbers. So let's solve further and see where it takes us. Okay. Y into x square plus 1 is equals to x square. Mhm. And then let's bring this expression to the left hand side. Y x square plus y minus of x square is equals to 0. X square common, y minus 1 plus y is equals to 0. So x square is equals to minus of y divided by y minus 1. Now we can also like multiply minus in the numerator and the denominator. This becomes y and this becomes 1 minus. Agree? And further on, agree?
Yes, sir.
Yeah. X square is equals to y upon 1 minus y. Now bringing the square to the right hand side. Now we knew from the question that our domain for x was real number. So we know this has to be a real number. Now, as we know, square root of any negative number is imaginary, which is not real. So this has not to be negative. Okay. So for all values of y for which this become negative, we have to we don't have to consider those values. And also 1 minus y must not be 0. Why? Because if it becomes 0, then y by 0 will be an undefined term, and which will make our x undefined, not defined. But the x is a real number, so we have to avoid two conditions. We have to avoid two conditions in which one condition that that this term y upon 1 minus y must not be negative, it has to be positive, and y cannot be equals to 1. These two conditions. So this has to be positive and y must not be 1. Clear?
Yes, sir.
Yeah. So if we solve this inequality further, so simple idea is to cross multiply. So y has to be more than 0. And 1 minus y, when it will get multiplied to 0, it will vanish. So this is one result and this is another result. Now, if we take, okay, so y has to be greater than 0, considered, and y has not to be 1. So let's draw a graph where we are discussing about this term, y upon 1 minus y. And now 1 is 0 and one term is 1, plus of infinity and minus of infinity. Now discuss about the term inside the square root only. So for all the values less than 0 for the negative y's, this is definitely going to become negative because 1 minus, let's take minus of 1 for example, minus 1 upon 1 minus minus plus. So this whole term has become minus of half, which is a negative. So we have to avoid all the negative values. So this is all has to be ignored. So these values will not be taken. Y is equals to 0. Can we consider y is equals to 0? Yes, y is equals to 0, we can take it. So this, let's draw a node here, and this filled shape represents that we are taking y is equals to 0. And as we have drawn out this conclusion that y has to be greater than 0 and y must not be 1. So if we are not considering 1, so let's make a hole here. Okay, let's now we are very sure about all the values lying between 0 and 1. Let's check half. Let's check for half. Half upon 1 minus half becomes half, and 1 minus half becomes half, half, 1. So that's a positive value, not a problem. So all the values between these, we can consider them. Now values for greater than 1. Now for greater than 1, we will take values greater than 1. So this numerator will be positive. Great. But what about the denominator? Here, if the y will be greater than 1, then this will become negative, and it will make our whole expression as negative. So we have to avoid these values also. These values also. Clear? So y has to be, it can be 0, but it cannot be 1, and the value should be lie in between these two. Clear? Any doubt?
Yes, sir.
Yeah, so this is our range. Range is codomain as this is a onto function, surjective function. So it is what we have to find. Answer should be A. Yes, it is. See how they have solved. They have considered y is equals to this, then x. And now this particular term has to be, it can be 0, should be more than 0, more than 0, so it should be positive. So for finding this is the, there's it directly written here without explanation. So it's a book. Okay, let's now discuss about constant function. We have already discussed about these. That a constant function is a constant function which is not dependent on a variable. Identity function. A function is said to be an identity function when the input is equals to the output. And range domain is real numbers, codomain is also real number. Polynomial function. A function having a domain and codomain as range. So h real numbers defined by f of x is equals to a naught plus a1, a naught, a1, a2. These are all real constants. Real constants means they are real numbers. And n is a non-negative integer. Non-negative integers are whole numbers basically. Okay. So this is what polynomial functions is. We have also discussed in quadratic equation. Now discussing about rational functions. P of x is this term, basically a polynomial, and q of x is also a polynomial function, and their division, if they are like getting divided, it's called a rational function, and q of x must not be 0. Exponential function, the function defined by e raised to power x, x belonging to real number, called an exponential function. Domain of this function is like real numbers. Any number can be put in any real number, and but the range is from 0 to infinity. An exponential function can never become negative, as from the graph you can also see. Is the screen visible?
Yes, sir.
Yeah. Discussing about logarithm function, the function defined by logarithm, we have also covered this chapter. So the domain should be positive and must not be 0, and the range is all real numbers. You can observe the graph. Clear?
Yes, sir.
Yeah. Discussing about trigonometric functions, we will discuss more in trigonometric chapter. The functions involving circular functions, variable angles are known as trigonometric functions. Always remember that angles are positive when they are counted in an anti-clockwise direction or counterclockwise direction. If they are measured anti-clockwise, then they are positive. If they are measured clockwise in this fashion, then they are measured as negative. So this is sine function. Its domain is real number. Real number. Its range is -1 and +1. Means the minimum value of sine can be -1, and the maximum value can be 1. So accordingly, you can see all. And here n belongs to integer. It means that all the odd multiples of pi by 2 are excluded from the domain for 10. Okay.
Yes, sir.
So similarly, you can have a look on these later on. Now discussing about absolute value function, modulus function. Y is equals to modulus of x. Simple. Its function is I don't care. I don't care whatever is inside. I'll make the outcome as positive. If the inside term is negative, like if x, the inside term, considering inside term as x, if the x is negative, so I'll multiply and negative number to x to make it wholly as positive. If x is already 0 or positive, so I don't care. The inside term will remain the same. So this is how we write it. Square root of x square is also written as modulus of x. Okay. Why? Because only positive value of x is considered here. So let me give an example. X square minus 4. Now for all values, now please tell me how this will behave. If we open this particular function, for these conditions, I have written them in a wrong manner. For these conditions, how will this function opening, where they have gone? Okay. So for x more than 2, x less than 2. For x more than 2 and equal to x. So where should I apply a negative sign, here or here? Where?
Is it the second one, sir?
Yes. Because if this is becoming negative for that particular range or for that particular domain, then we are going to apply a negative sign to make it wholly positive. Okay, in totality, it will be positive. Clear? Any doubt, Tanish or Yarini?
No doubt, sir.
Okay. Properties of modulus function. Simple. If this is less than a, then means it means that it is the x values is lying between these two. And if it is more than a, like modulus of x is more than a, then x is going to be less than minus of a or more than a. And this is triangle inequality. Just read them and have like take some examples by yourself by taking random values of x and y. Then you will be able to understand them on a great level. Okay, so that's like your homework. Take x, take at least three different values of x and y. Change after changing their signs. Okay, that's when you will understand this triangle inequality. Give me 2 minutes.
Yes, sir.
So, like common understanding also. Are you there, both of you?
Sir?
Yeah. It's also common understanding the sum of two terms, two numbers are always going to be more than the sum or difference of two numbers. Okay, so take examples, you'll be understanding it more. Take. So, क्या होता? What if there were a function which can tell us the sign of any number? And this is the signum function. This basically tells the sign of a function. So if your number is less than zero, if a number is less than zero, it's a negative number. So this function will give a output for numbers less than zero as minus of one. If your number is zero itself, so it's the function's output is zero. If the function is more than if your number is more than zero, then function's output will be plus one. So the function has only three outputs: minus one, zero, one. One output represents then that your number is more than zero. Minus one output represents that your number is less than zero. Zero represents that your number is zero. The input is zero. So basically how this function works, it is if the number is not zero, if the number is zero, so it's of course zero. And if it's not zero, then it is calculated on this basis. Modulus of x upon x. And in derivatives, we have also understood this fact that the derivation of modulus of x is modulus of x by x, except x is equals to 0, because on x is equals to 0, x is not derivable, differentiable. Why so? Because there is a corner point. So there will not be one slope which can be drawn on this particular point. So the modulus of x is differentiable at all points except x is equals to 0. So the differentiation of modulus of x with respect to x is modulus of x upon x, or we can also write it as x modulus of x, except for x is equals to 0. For x is equals to 0. Clear?
Yes, sir.
Yeah. So this is basically signum function. Its graph is it have only three values, plus one, minus one, and 0. Okay. It is written as signum x. Domain is real numbers. Range is only three elements. Clear?
Yes,
We can
sir.
also take examples. For example, if we take any negative number, say 304. So according to signum function, as it is not a zero, so modulus of minus 304 upon 304. So this is become 304 only. And sorry, this is minus also because x is minus 304. So becomes 304 upon minus of 304. This cancels. Minus 1 is the answer. So hence the function is also tested. Okay, clear?
Yes, sir.
Even and odd functions, we have already discussed about them much, that this is an even function and this is an odd function. Simple. So derivative of an odd function is an even function, and derivative of an even function is odd function. We have already discussed this. The derivative of odd function is an even function. Okay. Each function can be expressed as a sum of an even and odd function. Let's discuss this more. So here is the formula for that. Any function can be written as a sum of an even function and an odd function. To do so, simply write f of x is equals to sum f of x plus f of minus of x by 2 and plus f of x minus f of minus of x by 2. So this particular part is basically the even function, and this is basically odd function part of the already existing part. Okay, clear? So this is how each function can be expressed as a sum of even function or odd functions. Let's take an example. Um, let's take example of sine of x. Okay. So how we can write this function as a sum of even function or odd function? So simply writing f of x only, sine of x plus sine of minus of x, sine of minus of x divided by 2 plus sine of x minus sine of minus of x divided by 2. If we solve this further, sine of x um, minus sine of minus x is what? Is minus of sine x only. 2 plus divided by 2 sine of x is this. Now minus minus will become sine of x. So basically this is 0, which is an even function. F of x is equals to 0 is an even function. And this is basically sine of x only, which is an odd function. Clear? Because sine of minus x is minus of sine of x. Minus of sine of x. That's why this is an odd function. So basically, this the function was already an odd function. That's why we had to call 0 as an even function here. If there are some functions also which are there are some functions which are neither, which are no, which is neither even nor odd. Okay. So for these kind of functions, we can use this particular formula to write them in the sum of even and odd functions. Clear?
Yes, sir.
Okay. So this point is also the graph of an even function is symmetrical about y-axis, y-axis. This is y-axis, this is x-axis, this is y-axis, this is origin. So the graph of an even function is symmetrical about y-axis. Okay, if you look from y-axis, you will see similar graphs on the right hand side and as well as left hand side. And the graph of an odd function is symmetric about origin. If you look from the origin, then the graphs will be symmetrical for odd functions. F of x is equals to 0 is both an even and an odd function. F of x is equals to constant. There's a contradiction, I guess. There's a contradiction. Yeah, here. Every constant function is an even function. F of x is equals to 0 is an even function as well as an odd function. No, there is no contradiction. We have to write. Remember that f of x is equals to 0 is both an even function and odd function. And also 0 is both a purely real number and as well as a purely imaginary number. We'll understand more about this in complex number chapters. Okay. Any constant function is an even function. Same points have been repeated here also. Every constant function is an even function, and 0 is an even and odd function as well. Even functions are many even functions. Why? Because f of x is also f of x, and f of minus of x, f of minus of x is also f of x. So for two different inputs, there are same outputs. That's why in mapping it will be written like this. So this is a many one function. Clear?
Yes, sir.
Yeah. So all the points have been explained and discussed. Let's go further. So example, which is an interesting thing to do. If f is an even function, so it is given that f is an even function. So for even functions, we can write as this, like right. So defined in the interval. So the domain is also given. Sorry, domain is also given. Okay. Then the number of real values of x satisfying the equation. Okay. And one more property of the function is given to us. Now, from observing second equation and first equation, we can observe one pattern. Let me write it differently. Uh, let me write it in different manner. We just change the LHS and RHS. This is also an even function, right? So we have just switched LHS and RHS. Now, if we observe these two, so x, here is also x, which is minus of x. So let's only compare the variables. So on comparing x must be equals to this. First, let me hear it in a different manner. So if f of x is equals to f of x plus 1 upon x plus 2. So if f of x is equals to f of minus of x, so let's substitute that. Okay, we have successfully done that. Now we have used the given information that the function is an even function and also what was given to us. Now let's try to equate the variables on minus of x plus 1 upon x plus 2. Okay, can we do so? Can we like in a way if this is somehow equal, like how should I? Okay, if this is somehow equal, so we could have just taken the variables out differently. Okay, so we can take the variables out and compare it. Are you able to understand just like writing it as sine of 3 of x, sine of 3 of p, let's say 6p. So we can just take 3x and 6p and compare them. Similarly, we are doing. Any doubt?
No, sir.
Okay. So solving this further, minus of x into x plus 2 is equals to x plus 1. Now taking this to the left hand side, x square minus 2x 3x plus 1. Okay. So this is we have solved. 0 is equals to x square plus 3x plus 1. What we had to find out? The value of x, right? How many real values of x are satisfying the equation are possible? So first let's find out x is equals to minus of b, 3 plus minus square b square minus 4ac upon 2a. Okay. So minus 3 plus minus root 5 by 2. So these are two values. These are two roots of x here. So these are both real. Real. Okay. So there are two values of x now. But there was also one condition. We have utilized this only. Now, after using 1 and 2, we have made this equation, utilize this. There was also this information given. Okay. So if we utilize this given information, then we also have to consider x is equals to x plus 1 upon x plus 2. Clear? Any doubt? Any contradiction?
No, sir.
Now let's solve this. Then bringing this to the left hand side, x squared plus 2x is equal to x plus 1. Bringing this term to the right hand side. So now applying Sridharacharya formula, minus of b plus minus square root of b square minus 4ac. So 4a is 1, c is minus of 1 upon 2a. So x is equals to this minus minus becomes plus, this becomes root of 5. So 1 minus plus minus root 5 by 2, which is real number. So these are two roots of x here, two roots of x here. So how many roots complete? There are four roots. Clear? Any doubt? Any doubt?
No, sir.
Yeah. Let's see whether our answer is correct or not. Here is the solution. Okay. If this will not be correct, I'll tell you later. Otherwise, it's correct. Let's discuss periodic function now. So it's simple. Let's take one example of trigonometric function to understand it. Okay, I'm want to draw sin x. But I have drawn it very high magnitude. Should not be the case. Okay. So good, very good. Now this is my best drawing. Best. Okay. So let's understand what is this. So this axis represents x, and our function is sine of x. So this axis represents sine of x. Let me draw values. So for sine 0, the sine 0 is 0. For sine is equals to sine pi by 2, sine is 1. This is 1. For sine pi is 0. Sine 3 pi by 2, where I'm writing 2 pi by should write pi here and 3 pi by 2 here. And this is 2 pi. And this is 5 pi by 2. This is 3 pi. This is 7 pi by 2. This is 4 pi. This is 9 pi by 2. This is 5 pi. This is 11 pi by 2. This is 6 pi. This is 13 pi by 2. So my point is that after every period of 2 pi, after every period of 2 pi, the sine is repeating its curve. So 2 pi till here. The sine is repeating its curve. Okay, sine is assuming same values, like start from here to here, like 0, 1, like this. But here we have to consider one more thing also. Mm, So this is minus of pi by 2. This is minus of pi. as we were discussing about sine of x, its domain was real number, but like principal domain for minus pi to plus pi. Sorry, if we take from here, this is minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. It is repeating. We take this much. We take this much only. We take this much only, this much only, this much only. So it is repeating its value. So its period will be pi. Um, to show you an example, I actually copying graphs from Google will have copyright issues. So basically, if you are able to understand from this picture, what is happening is there is a pattern, right? There is a pattern. There is a pattern. After there is a this is a wave, simple wave. Try to understand this like from here to here. This is a wave, and using this wave, I can copy paste and make the whole graph. So basically, after 0 to pi and pi to 2 pi, so basically from 0 to 2 pi, the graph is repeating itself. After 0 to 2 pi, there are unique values of sin x. Otherwise, if we just go ahead, then 2 pi, and also we consider 2 pi as 0 because 2 pi is the period of sin x. That is why. So after 2 pi, the graph is repeating itself. So that is the reason. That is the reason. That's the reason. And that's why we call 2 pi as the period of sin x. And now what is the significance of this? So significance of period, if we write f of x, then its value, the value of x is equals to the value of x plus t, which is a period. So let's understand from this. Sine of x will be equal to sine of 2 pi plus x. Okay. And even if you like multiply that period with any integer, let's say 2 pi into 2, so 4 pi plus x, it will be also the same. It will be equal to sine of x. So this is about periodicity. Now let's read the definition. If a function from x to y is said to be periodic function, if there exists a positive real number t such that f of x plus t, as t is the period here, is equals to f of x for all x element belonging to set x, okay, belonging to its domain. The least value of t is called the fundamental period of a function. Now, if we see for according to this is also period. 4 pi is also period of sine function. But 2 pi is the least period, so that's why it is called fundamental period of sine x. Okay,
Yes,
the
sir.
value of t is called the fundamental period of function. In general, the fundamental period, the principal period, is called the period of a function. Graphically, the graph gets repeated after each period of the function. We can also observe it the duration of 2 pi. Okay.
Yes, sir.
Now let's discuss with the properties. Basically, the properties are not that much important. What's most important is you have to understand simple fact. The T is the period here. Simple, as simple as that. In NDA, questions have been asked from this particular topic, asking what is the period of given function. Let's see the properties. If f of x is a periodic function with fundamental period t, then 1 by f of x will also be a periodic function with the same fundamental period. So if there is a function given like this, so its period, basically this is cos of x. So its period will also be 2 pi because sine of x period will be was 2 pi. Okay, clear?
Yes, sir.
This is the second property. If f of x is a periodic function with period t, then f of a plus ax plus b is also a period with is also a periodic function with fundamental period. Now its period will get changed, will get divided by modulus of a because a was getting multiplied to the variable. So if we have to find out the variable of sine of 5x, so its fundamental period will now become, as it was earlier, 2 pi divided by 5. Okay, and plus minus b doesn't matter. If f of x is a periodic function period t, then a into f of x plus b is also a periodic function with same fundamental period. Now this time a is getting multiplied to the whole function, means 5 of sine of x plus 2, its fundamental period will still remain the same, that is 2 pi. Because 5 is getting multiplied to the f of x, not to the x this time. Clear?
Yes, sir.
Okay, great. If f of x and g of x are two functions with fundamental periods t1 and t2 respectively, then the sum of two functions is a periodic function with fundamental period of LCM of these two fundamental periods, provided they cannot be interchanged by adding a positive number in just like that. Okay, so basically has to be there has to be there has to be some difference in these two functions which should be greater than the LCM of fundamental periods. Clear?
Yes, sir.
In that case, period becomes that number, and also LCM of T1 and T2 should exist, otherwise this is not a periodic function. We'll take examples. Um, okay. We're taking f of x as sine of x and g of x as cosine of x. The both fundamental period is 2 pi because their graph is somewhat similar. So now if we make a new function and sine of x plus cos of x, its fundamental period will be the LCM of both of these two. Now what will be the LCM of 2 pi and 2 pi? What is the LCM of 24 and 24?
LCM of 24 to 20.
And 24.
Um,
You will understand by this. If we have to solve this, so what will be the
it
LCM?
is 24, sir.
Yes, so the LCM of 2 pi and 2 pi will also be there.
Then 2 pi.
So now the periodic function, and now the new functions fundamental period is also 2 pi. So provided f of x and g of x cannot be interchanged by adding a positive number in x, which is less than LCM t1 and t2. Okay. So this is a condition which should not happen. Okay. Discussing the fifth property. Is this point clear?
Yes, sir.
Any doubt?
No, sir.
Okay. Fifth point. If f of x is a periodic function in period t and g of x is a monotonic function, then g of f of x monotonic function is like strictly increasing or decreasing function. G of x, let us go g of x. So g dash of x with this should be the case for whole x domain, then it will be declared as a monotonic function. Then g of f of x is also a periodic function with same period t as that of f of x. Now, okay, so this is a periodic function with period t and g of x is a monotonic function. Then the composite function is also a periodic function with same period. Okay, this is something to remember. So let's take one example in which let's take g of x, a monotonic function. So this is a monotonic function because its derivative is positive plus 55. And we take that f of x is a periodic function with period 2 pi here. So now the 55 into sine of x is also a periodic function with same fundamental period. Okay, understood. Got it. Clear and doubt?
No doubt, sir.
If you have taken this also, then only this is a period with having 2 pi only because its derivative is 55 into 3 into x square, which is always positive because x square cannot be negative, and 55 into 3 is itself positive. So that's why this property is working. Clear?
Yes, sir.
Yes. So let's now discuss the examples. I'll bring more previous year questions in tomorrow's class. We will solve the previous year questions. And I'll try that will take more the class of like more duration, 2 hours or so more. F of x is sine of x by 3 plus cos 2x by 3 is a periodic function with LCM of 6 pi and 3 pi. So period of f of x is 6 pi. So they have get added, and now the fundamental period of this is 2 pi divided by the uh, by the by the constant which the x is getting multiplied by 1 by 3. So it is its fundamental period. Discussing about this, so 2 pi divided by 2 by 3. So this is basically 2 pi into 3, which is 6 pi, and this is 2 cancels 2, 3 goes up, which is 3 pi. So understood how 6 pi and 3 pi are here. And the LCM of 6 pi and 3 pi is 6 pi. So basically 6 pi is the periodic is the fundamental period of this f of x. Clear? Any doubt?
Clear, sir.
Great. So let's now discuss this question. So given f of x be a function, k be a positive real number. Okay, k be a positive real number. Such that f of x plus k plus f of x is equals to 0. For all x belonging to real numbers. Okay. Then f of x is a periodic function period. So we need to find out the period of this f of x. Okay, so for finding out the period of f of x, we need to write it in this format, right? We need to write it this in this particular format. So trying to simplify this minus of f of x. So okay, now we know that we can change variables as per our convenience in the function because we are just changing the input, the output will itself change. So let's change the input both on both of the sides, and what we can do here, we can add something on both of the sides. And why we are doing so, because if we will add k here, let's say, x plus 2k. So this will also become x plus k, which may help us in some way. Okay, so coming back. Okay. So, this was the question. Now we were discussing about making changes in the variables. So we can add something and let's add k on both sides because the reason I have already discussed x plus k. Agree or do you contradict, sir? How we can do so?
Yes, sir.
Agree. Very easily.
One. Um,
Yes,
Perfect. Is it K or 2K there in the right side?
2k. We have added k to the variables of the function on both sides. Okay.
Hmm.
Now, f of x plus k is value we have already, which is minus of f of x, right? So minus of f of x minus minus plus. Clear?
Yes, sir.
Now, can you tell me what is the period of f of x? See this. T is the period here. Now, what is the period of f of x here? It's there in front of you. I'm not leaving this class if you don't complete the function chapter. After what value of f of x is assuming its same value after what change in variable? What is the
2K.
period here? Huh?
2K.
Yes, speak. 2k.
2K.
2k is the answer.
Oh,
Okay. So identical functions, we have already discussed about identity function. They are same. The output will be the same. The two functions are equal functions if they have same domain and range. Explicit functions if y and x can be separated. Implicit functions if y and x cannot be separated. Invertible functions, one, and onto functions. Example. So we have to find out the inverse of this particular function, assuming this as y. Y is equals to e raised to power x minus e raised to power minus of x upon e raised to power x upon e raised to power minus of x plus 1. So we have to find out the inverse. So first let's find out the x. So bringing the 1 on the left hand side, e raised to power x minus e raised to power minus of x upon e raised to power x plus e raised to power minus of x. Now let's write this in the denominator. Okay, so we know now. Do you know what is component and dividend rule? We have discussed this in the basics. Compo, componendo, componendo, dividend rule. It says if
A
a
by
plus
B is equal to C by D, then A
ah,
plus B
ah,
by A minus B is equal to C plus D.
okay, so we can apply the same logic here. So 1 minus 1 divided by 1 plus 1, 1 minus 1 minus 1. Now e raised to power x minus 1 by e raised to power x plus e raised to power x plus 1 by e raised to power x divided by e raised to power x minus 1 by e raised to power x minus e raised to power x minus 1 by e raised to power x. This cancels. and this becomes y by minus 2. This becomes this cancels and this becomes 2 e raised to power x divided by this. No, this not get cancelled. This cancels each other and divided by 2 divided by e raised to power x. So if e raised to power x goes to the numerator, this becomes 2x. 2 cancels. So basically now we have y minus 2 equals to 2. Um, yes, no, 2 would cancel. So not, no, there will be not be any 2. So minus 2 e raised to power 2x. So this says this. Now we have to find out the value of x. Okay, let's bring the negative sign on the left hand side by doing this. Clear? Now taking logarithm on both sides. So logarithm to the base e of y to minus y. Logarithm of e 2x. So this simply becomes 2x. Do you agree? Do you agree or should I explain?
No, sir. I agree with it.
So this is become 2x. Hmm. So the value of x now is this 2 will go in the left hand side like this, and this goes to the power. So x is logarithm a square root of y upon 2 minus of y. So this is what we have. Yes. So this should be your answer. Half, anything raised to power half, it means square root only. Okay. So this should be the answer. Where is the, yes, this should be the answer. Where is the explanation? It is the answer. So any doubt? Any doubt?
No,
No doubt.
sir.
So let's conclude our class fastly. Otherwise, there will be chaos.